Okay, here in lesson 2, for sine and cosine functions, we are now looking at the cosine graph. Really only one major difference in the cosine graph versus the sine graph. And that is simply that we do not start on the midline, we start with the amplitude. Other than that, there's really not a lot different to doing these graphs. So remember with the sine graph, the three basics that we started with, we had our vertical shift, our b value helped us establish the period of the graph, and then the a value dealt with the amplitude of the graph. All of that is the same with the cosine graph. So again, the only difference that you're going to see within these cosine graphs are just where you start. But from there, it's a lot of the same kind of thing. We still will deal with the midline or the center of the graph. So that's one of the first things that we always look for, and then we sort of expand from there the same way that we did with the sine graph. So here's just the idea of the parent function with the cosine graph. So again, if you look at the most basic form here, the parent function, notice it's centered at the x-axis, just like the sine graph was. But again, the only difference that you're seeing on this is that it doesn't start on the midline. It starts with the amplitude, then goes to the midline. With the sine graph, the pattern always went midline, amplitude, midline, amplitude, midline. That was always the pattern of the sine graph. The cosine graph is just the opposite of that. It starts with the amplitude, then goes midline, amplitude, midline, amplitude. So it's just sort of the alternate pattern for what we had with the sine graph. So that's what makes these simple. If you understood the sine graph, is there's just not a lot more to doing this. So let's just go through a couple examples here. So here's the first one. Again, we always start with our vertical shift. So with the sine graph, again, I always kind of worked in the pattern of CBA and kind of went down that order to help create the graph. So you'll notice on this one, there's no vertical shift. There's no plus or minus any constant that would shift our graph up or down. So we know that it is centered at the x-axis. So the midline of this graph we know is right here on the x-axis. So I always come up with that part first, then turn to the b value to help with the period of the graph. So in this case, you can see that our b value is 2. So I know that the period is 360 divided by 2, which means every 180 degrees on this graph, I should see one full period. One full period would look like this. So that is one full period of the graph. And so that's what I should see every 180 degrees for this graph. Just like what we did in the sine graph, I'm always going to take the period and divide it by 4 to see how often I should be making a mark. So for this one, every 45 degrees I should be making a mark on this graph. And then the last one we want to take a look at is the a value. So in this case, the a value you can see is just a 1 because there's no other number written there. One thing I mentioned with the sine graphs that you always want to keep in mind is that the a value helps us find the amplitude. So in this case, our amplitude is 1. And the reason I bring that up is to remember that the a value can be positive or negative, but the amplitude is always stated as a positive. And so I'll keep pointing those out with the 3 examples that we're going to do in this video. So the a value is 1. The amplitude is also 1 then in this graph. So our first mark we always make on somewhere on the y-axis. So again, with the cosine graph, remember you now start with the amplitude instead of starting on the midline. So because this one has an a value of positive 1, I'm going to start 1 unit above the midline of the graph. And so that's our first point. According to this, I should be making a mark every 45 degrees. So here's going to be my next 45 degrees. That's my next 45 degrees. This is my next 45 degrees. That's my next 45 degrees. So I should be making a mark every 45 degrees. And remember, the pattern just alternates from the sine graph. The sine graph went midline, amplitude, midline, amplitude, midline. That's the sine graph, but the cosine graph does the opposite. So we start with the amplitude, then go to the midline at the next 45 degrees, then amplitude, then midline, then amplitude. And so we just alternate like that. So here is one full period of this sine graph, or sorry, cosine graph. Will look like this. And once you get one period of the graph, you just repeat the pattern from there. So you just have to establish that one period and then just continue the trend. And so if I wanted to just keep going on this, again, I'm making a mark every 45 degrees because of what we did right here. So I just continue the pattern. I'm back to the midline, amplitude, midline, amplitude. So here's what that graph is looking like to the right. If I want to continue it on into the negatives, again, just continue the pattern for what you see here. So as we're at the amplitude, again, making a mark every 45 degrees. I'm back to the midline, amplitude, midline, amplitude, and you just continue that pattern every 45 degrees until you run out of room. So again, you know, like with what we saw with the sine graph, typically a domain will be established for us for how far to continue this graph. And so you're always kind of looking for that. So there we go. So there's the cosine graph from negative 360 to positive 360 for that function right there. And so let's just, again, this is just going to be kind of more of the same, just to give you a few more examples, but I'm trying to give you a couple different looks as we go through, just so you can see a couple of the variations from function to function, but our process won't change. So I always want to consider my vertical shift first. And in looking at this graph, again, there is no plus or minus any constant to consider. So I know there's no vertical shift, which means we are centered at the x-axis at 0. So there's the midline of the graph. That's always important to establish because everything is based on where the center is. That kind of always tells us how far we should be moving up or down from the center, from the midline of the graph. So we see our C value was 0, so we are centered at 0. So now we look at the B value. So in this case, think of this as 1/2 x. So for the period, we're going to do 360 divided by B. So if we did 360 divided by 1/2, which is the same thing as 360 times 2, then we have 720 is one full period of the graph. I'm going to break that up into 4 equal parts so we can see how often I should be making marks on the graph. So every 180 degrees, I should be making a mark on this graph based on this period. So the period is 720, but I'm going to be making a mark every 180 degrees. And then the last thing we always take a look at is the A value. And again, the A value itself can be positive or negative, but the amplitude is always stated as a positive. So the amplitude of this graph is 3. So we have everything we need now to make the graph. So again, our first mark is always going to be somewhere on the y-axis, and it's always its relationship to the midline. So because this cosine function has an A value of positive 3, that means I want to start 3 units above the midline of the graph. And so that's why we always establish the midline first, is because that helps guide us to where we make our first mark. According to this, I should be making a mark every 180 degrees. So remember, the pattern of the cosine graph does amplitude, midline, amplitude, and then I would be going back to the midline, but we are past the domain, so we don't go any farther. So with this one, we're kind of seeing half of the graph, like half of a period within this one. So we're getting kind of that half of the period. If I want to continue on into the negatives, as always, you just continue the pattern. So since we started with the amplitude, At the next 180 degree mark, I should be back onto the midline. And then amplitude on the other side. So remember what we're seeing with this. We saw right here that one full period should be 720 degrees. Well, from negative 360 to positive 360, that is a total of 720 degrees. So it makes sense that we are seeing one full period of the graph from negative 360 to positive 360, since that's a total of 720. So we're going to look at one more example, and then I'm going to show you how to view these on the calculator as well. Always something we should know how to do. If you're doing this again just for practice or for the first time, this is a good point to pause the video and give one a try on your own. So I'm going to start this the same way as all of them. I always identify a vertical shift first. So you can see that we have positive 1 as our vertical shift, which means this whole graph was shifted up 1 unit. So everything we do is going to be based on this as the center of the graph. So right here we have the midline of the graph, and then we kind of move forward from there. You can see right here that the B value is just 1. So for the period, if I did 360 divided by B, we can see that one full period is 360 degrees. And you'll get a few questions that just ask you what's the period of the graph, so that's always important that you know how to find that. So our period is 360. I'm going to break that up into 4 equal parts so that I can see how often I should be making marks on my graph. So if we did 360 divided by 4, that means every 90 degrees I should be making a mark on my graph. So the period is 360, but this is how often I am making marks. And then again, the A value on this one is negative 2. So just as a reminder, the A value is negative 2, but if you are asked what is the amplitude is positive 2. So the amplitude can go either up or down, so that's why we always state it as a positive. The amplitude is a length or a distance, so we always state a distance as a positive number, even though the variable that is represented here by A can be a negative. So the reason for identifying A as a positive or negative is because it tells you whether you should be starting above or below the midline. Because it's negative 2, that means I should be starting 2 units below the midline of the graph. So identifying A as a positive or a negative is really important in establishing whether or not you're starting above or below the midline. So again, we know the amplitude itself is always stated as a positive, even though the A value is negative. Okay, anyway, from here we just continue the trend. I'm going to be making a mark every 90 degrees. Remember the pattern of the cosine graph always does amplitude, midline, amplitude, midline, amplitude. So there we go. We have one full period. And again, just to kind of highlight this idea as far as an amplitude is concerned, you can see right here we identify a total length of 2 units for the amplitude, and the amplitude is consistent all the way through. So from here to here, I can also see that there is a total length of 2 units. And again, if I wanted to view that everywhere possible on the graph, right, you can see that amplitude is consistent from the midline of 2 units, whether it's up or down. So that's why the amplitude is always stated as a positive, is because we can do it from midline to the top or from midline to the lowest point. Always shows us that distance using our amplitude. If you wanted to continue the trend on into the negative, just continue the pattern. So we were with the amplitude. At the next 90 degrees, I'm back onto the midline, amplitude, midline, amplitude. So there's our cosine function. Let me show you one real quick on the calculator just so you can see it. Make sure that your calculator is in degrees for this. So right here you should see that you're in degrees. If not, you can go into mode and change it into degrees. But I'm just going to type in the function that we are using for this one. So 1 minus 2 cosine x. The window I'm going to use, again, is according to what I see right here. My x values should be going from negative 360 to positive 360. My y values, I'm going to just keep these guys in mind. Right? I want to be lower than the lowest point and higher than the highest point. So something like going from negative 3 to 4 would be a pretty good range. You can change that a little bit. You just want to make sure these guys are covered from bottom to top. So I'm going to go into my window, and again, you can see what I did with the x's from left to right. From bottom to top, right? I like to use tens just because I make sure I get all the numbers covered that way. You would rarely go outside of that. If we do, I'll show that in the next video. So anyway, there's our window. If we hit our graph, I should see a very similar graph to what I did on the notes page. Let's see if we can get all that on there at the same time. So you can see that's pretty good. So we're seeing the same image on both things. So the calculator is a great way of just confirming that you did it right. We will use the calculator more in the next lesson as we do some application problems, but in a test question or even in a homework problem, this is a great way of checking an answer to make sure that you're doing it right.